Now that you've gotten an overview of the Java Executor framework and some of the key interfaces and the factory methods in the executors, utility class, et cetera, it's time to start taking a deeper look into the different interfaces and how they behave and how you can implement them, or how they are implemented by various classes that are part of the Executor framework. So we're going to begin our discussion with the Java Executor Interface, which is, as you'll see, super duper simple. Probably too simple, but it's very simple. So the Executor Interface, as I alluded to earlier when I gave you the introduction to this, is a way of submitting new tasks for execution. It has a single method called execute that takes a runnable. And the purpose of this is to decouple the submission of tasks from the mechanics of how each task is run, how they're implemented by whatever implementation of the Executor Interface you happen to choose. Just like execute is a functional interface, the parameter passed to execute, runnable, is also a functional interface. And that means that you can do certain tricks to make things a bit more concise, which is nice. You can think of a runnable as essentially being a command to execute. Now, you've seen runnable before because that's what's used for Java threads. When you say new thread, you give it a runnable of some form. And you don't really think of that as a command per se. At least I don't think of it as a command, but it is a command. But when you start using the Executor interface with execute, then this really does become a command. So this is the command or a task that you're giving to the framework to execute at some later point in time. In other words, when there's a thread ready to do the processing on the task. And this particular approach, this command, is another pattern from the good old Gang of Four book called the command pattern. And if you read the Gang of Four book, you'll see that a command pattern encapsulates all the information needed to perform an action or trigger an event later in time. When you start using runnable with the Executor framework, then it really becomes the command processor pattern. And the command processor pattern is a pattern from the POSA 1 book, Pattern-Oriented Software Architecture, Volume 1 book, A System of Patterns, with a bunch of colleagues that I later wrote a bunch of other books with. And what the command processor pattern does is it packages a piece of application functionality as well as its parameterization in an object to make it usable in another context. That's the intent, or that's the abstract description of the pattern. What it really turns out to be in practice is you can submit requests that are called service requests, or in our case are runnable, and you give them to somebody to execute them. And what the pattern then calls a command processor is basically the implementation of the Executor interface. And so then the command processor will execute those requests in another context. And in the context of the Executor framework, that other context is typically a thread from a pool of threads that's managed by the implementation of the Executor interface. So what I'm trying to do here is kind of help you see that the features that you'll find in Java are not just randomly put out, but in fact they are implemented according to the application of common patterns. So all the stuff that you learned about in intermediate software design and all the other stuff that you will learn about if you study patterns further really turns out to be quite useful to understanding the way in which concurrency architectures in Java and Android are put together. And you'll see this a lot. I try to go back and show patterns wherever possible to really give you a better feel for how Java is based on well-established, time-honored principles of good software design. Now, the Executor interface and its execute method and the use of runnables provide something we call one-way task semantics. And that means that the run method that's called returns no results. It's a one-way computation. You give it something to do, it does it, and there are no results returned directly from the run method because it returns void, right? It doesn't have anything to return. If you want to return something, whatever the heck that means in this context, it typically has to be done through side effects. And that means you'd have to have something that would update some other entity, like some variable, or send a message, or update some shared state somewhere. But you don't get it back as a result of invoking or executing the runnable. The runnable can actually execute in a couple of different contexts. It could execute in a background thread. That is by far the most common way to do things. Or it could be executed in the main thread or the calling thread or whatnot. And whether it executes in a background thread or in the calling thread or the main thread or whatever depends on the implementation of the Executor interface. So depending on how you set it up, it might execute in the background, it might execute in the calling thread. Who knows, right? It's not who knows, it's your choice. You get to decide where it goes. There's even a single-threaded executor implementation, which seems a little bit goofy, and it probably is. I think they just put it in there for completeness, but you would typically not do that. So that's the end of the Java Executor Interface. We're going to take a look at some more dimensions of this, and we'll look at an example to illustrate how it all works in a second. Be aware that this interface is probably too simple for its own good most of the time, and you'll learn more about that when we transition to the next set of topics, which is the Executor Service Interface, which has a lot more cool stuff as part of it.